Good afternoon.
Good evening, sir. So I'll just begin presenting. Wonderful to have you with us, sir. So hey everyone, and I hope my screen is visible right now. So welcome to the IoT Workshop conducted by CODS. So let's briefly go over the itinerary for today. We will have an amazing talk, firstly by Professor Satyaprasad, followed by three hands-on sessions, which are further subdivided into different events. All right. So a little bit about Professor Satyaprasad. He is the head of the Center for Innovation and Entrepreneurship in the RR campus of PES University. Sir is an amazing orator, and his knowledge is so vast on every single topic there is. Whenever we chat up a little bit, the conversation extends beyond half an hour at least, right? So I will speak no more and let Sir continue.
Okay, very flowery introduction, but thank you very much. And so may I know how many people are on at this point in time?
So at this point in time, there are 17 people. People keep dropping in and dropping out, so I'm guessing there are connection issues.
That's okay. Okay, so about 17 people. And can we just get a rough feel? Are they all from first semester? Are they a mix of first and third and fifth? What's the composition of the target audience?
Majority of them are in first semester, sir. I mean, these kids have, despite their ESAs going on, they have come in and tuned in for your talk, sir.
Okay, so we better make use. We better, make sure that we make the best use of their time. And first of all, folks, thank you for joining, and thanks to the CODS team for inviting me. So, what I'd like to do this is to tailor this so that it's most useful to you. Right? There is lots of stuff. So, just a quick background. About my background so that you have some context where I'm coming from. So I spent close to 20 years at Intel building. I started first by building microprocessors. I started as a microprocessor designer, and within design, I started with analog design, which is called the black magic of design. It's very, it's seemingly very hard to do, right? But then, just like what you're learning in your first semester or you learn in the couple of years, start with analog design, then digital design, then microarchitecture. How do you even architect this, right? So when somebody builds a home, the first thing that somebody does is to pull together a blueprint and say, this is what the layout looks like, much before you actually build the house. So and at a lower detail, it's called the microarchitecture. Then I moved to marketing. And finally found out all the stuff that we were building. Where does it go? How do the customers use it? How do the customers not use the product that you thought was the most wonderful product? Right? And then move to strategic planning. So why do we build the products we build? Why did Intel build the 11th generation core? Is it simply because it's got more frequency? No, I mean there's a lot of science and art that goes into it. And then I came back to India, set up the server division in Intel India, and so forth. Right. The reason I'm telling you all that is not so much as my reading my resume, but that's given a perspective, right, in terms of what IoTG means. And when you reflect on what IoTG means, well, IoT, G for group, IoT, I worked very closely with the IoT group, and therefore IoTG. And this is public information that I'm sharing with you. IoTG in 2017, 2018 was roughly a $2 billion business for Intel, right? And I'm sure it would have grown. Very important area, lots of growth. And I think we are just at the beginning of it. So what I want to do in the next 10 minutes, I'd like to keep this interactive. I don't want to, give you a lot of PowerPoint stuff. That's all available on the internet. But what I want to make sure is I hit a couple of key points, and I'll use an existing slide. I didn't want to make more slides for that, and then open it up, for discussions. And I have a class starting at 6, so I have a hard stop at 6. So I want to make sure we maximize the interaction and not so much as the presentation. So let me just pull this up. I think this is an interesting set of files that I found. This is from a conference that I attended. Let me just go ahead and share this thing and make a few key points, and then we'll open it up for Q&A. I hope that's okay. Let's do this, and yeah, okay. Wow, okay. Just how come this thing doesn't show up? Let's do the screen. Okay, screen one, that's this entire thing I'm sharing. So let's go to this, and I hope you can see my screen. Yes.
So your screen is visible now, sir.
Okay.
Yes, sir.
All right. Okay. So this is from a conference, Zenov. Zenov is a consulting company. So huge market. This is 2020 versus 2020, 2010 versus 2020. So I'm not going to say how big a market it is. All of this is on Google. But here is the big thing that most people miss about IoT. The minute you say IoT, they say, okay, Arduino, Raspberry Pi, some hardware, some Zigbee, which is a connection protocol, or LoRaWAN, I mean, all of that. That's great, right? But look at the first slide. First slide was the market opportunity, right? This is how big the market is. 6.3 trillion euros. It could be 6.3 trillion dollars, right? I mean, roughly give or take. Next thing they're talking about is they're giving an example of an industrial IoT, right? This is from, it's not mentioned here, but this is from GE, which is mentioned, but this is from their Predix platform, Predix, right? And essentially it changed the way GE did business. So GE builds jet engines, as you can see, and essentially what they said was, we'll not sell you jet engines anymore. We will sell you the number of hours that you use, and you only pay for that, right? And you pay for, you know, the quality of service, the uptime and such. So look at what's happening here, right? I'm just pointing to this increased efficiency, additional revenues, right? So they changed the business model. Remember, suddenly we were talking IoT, now we're talking of a business model. So if used correctly, the most powerful way of putting this all together is to look to say, hey, how do we use IoT to build digital transformation, business transformation and such, right? So first point, don't think of IoT as hardware or software, some sensors, gateway, that's all true. But I also want you to, and I'll leave you with some more specific things so that you can continue to develop that. But IoT can make a huge business difference. And there's a very nice Harvard Business Review case study on how GE changed their business model from just selling jet engines to saying, we'll sell you the number of good hours that the engine is with you, right? So that's their Predix platform. So that's point number one. Okay. Point number two is GM versus Tesla, right? So update your car while your car is parked in garage. So today, pretty much all of the cars that we have, anything that has been built in the last 5 years is an IoT car, right? Some may be less, some may be more. For instance, your BMW 5 Series, this was there even 5 years ago. They don't have a service manual. It doesn't say every 6,000 kilometers, 6 months you bring it in. You can keep driving it for maybe 9 months, 2 years, whatever it is. And when the car feels that something's not right, it automatically tells the BMW, and the showroom will call you, or the service guys will call you and say, sir, your car. And of course, you as a driver will also get a message saying that you should visit your service person as soon as possible, or in the next 2 days, whatever it is, right? So a huge change where cars are becoming essentially, mobiles on wheels, right? And this whole area is called mobility, right? You'll hear the word mobility, and Tesla is at the forefront, but that doesn't mean they're always going to be there. There are lots of people gunning for bringing in that. Here are 4 things to remember about IoT. When we first, at the lowest level, right? So what they have done here is their x-axis is functionality, which it will go over, and the y-axis is value, right? Value is, why people buy so why did I buy this mobile phone? I bought this mobile phone because it brings value to me. It could be communication, it could be compute, it could be connectivity, whatever it is, right? So at the lowest end is monitoring, right? Which we're all familiar with. Examples given: Fitbit, Medtronic, Schneider Electric, all these guys help you to monitor things, whether it's the industrial thing, consumer thing, health, and things like that. The next step up is not only do you monitor, not only do you sense, but you actually control, right? You have actuators that can actually help do something. A good example that's given there is Philips wireless lighting, right? You don't like the particular light, it's got 16 million colors. I can just pull out my app, I can change it, and I can watch, you know, if I have all the time in the world, I can keep changing the colors until, you know, I grow old, right? So that's the control part. The third one is to say, okay, what in the context of an organization or a business, how do I optimize something, right? So GE software, the one we talked about, GE Predicts platform optimizes for the uptime of the jet engine, meaning jet engines, if they have to be, you know, serviced, that aircraft is gone for a week, 10 days, 15 days, whatever it is, right? So I need to be able to schedule that service thing so nicely that anyway that plane is not going to be flying, that's when I need to do it, and a downtime of 10 days is okay, right? So that level of optimization that leads to business value, right? That's the third part. Finally, of course, nirvana is autonomous, right? So where everything, the monitoring, the control, the optimization, all happens automatically. There's a lot of intelligence built into it. How does the intelligence come about, right? The intelligence comes about from a combination of things. There's a combination of really good hardware, right? Some of the stuff that, you know, that I built a long time ago, some of the stuff that you guys are working on, right? An Arduino, a Raspberry Pi, and there are innumerable number of these kind of control devices, sensors coupled with control devices. That's one. The second is, and I'll talk, I'll share something, which is, you know, lots of software, analytics, and all of that. The third part is really putting it in the business context, right? An Airbus, for instance, Airbus can look at, you know, the joints through shear stress and shear mechanisms to say, hey, this airframe is worthy. And, you know, for instance, there are 737, Boeing 737 planes that are 30 years old and they continue to fly. How are they able to do it? They're able to put all these structural monitors and check that and say, hey, this plane may be 30 years old, but, you know, structurally the integrity is very good. Same thing with Airbus. So you must take all this, you know, sensor, gateway, all of that, plus the data, the analytics, and then try and solve a business problem. That's where the optimization comes. And so these are things, 4 things I want you to remember, right? Not just some hardware, software thing. What are we doing? We're trying to monitor something. The next stage is to control some of the things. It could be, you know, controlling the temperature in this room, where I, you know, have a sensor, and then it's connected to my air conditioner, and I can just say set it at 24 degrees, no more. And when I'm not in the room, never turn on the AC. So you know all that stuff. Then optimize. Then I combine this room with the next room, lighting, elevator, all of that stuff to say optimize my electricity bill, right? And then, of course, if you can do this all in an autonomous way, wonderful, right? So I wanted to leave you with these 4 things. There are many dimensions to it. The reason I wanted to quickly show you is the 5 Ps here: products, people, process, platforms, and partnerships. So this is not like, again, you know, I'm trying to move you away from just the hardware centric thing. Look at this. Products, yeah, they have hardware, software. People, you need talent. You need a method or a process by which you can do this. You see the word agile. So it's not just enough to say I can hook up a breadboard, but you know, you're just coming in. I would highly encourage you to, you know, look up Agile, A-G-I-L-E. If you go to agilemanifesto.org, you will find this thing. And if you say the word agile in your placements, half the guys will say, whoa, okay, you know, you're talking my language now, right? Today, all development projects, doesn't matter is hardware, software, people follow the agile method, right? So gone are the days where somebody would come up with a plan. At least when I started working, I mean, it was that way, right? Come up with a beautiful plan, put everything in it, and then give it to the team and say, okay, disappear for a year or 2 and come back with a product. Today, we don't build products that way. Right? So all of this stuff. So this is another thing, that it's multi-dimensional. It's not just about building a product. You need skill set, which is people. You need a method, which is process. Okay, people are waiting in the lobby, so somebody needs to be let in. Okay, which Kirit will help. That's it. And I think, you know, there are lots of startups. You know, it's out here. These are the big guys, but tons and tons of startups coming in, and that's, I think, a great opportunity for you guys to be innovative and entrepreneurial. And that's it. I don't want to bore you with too many things, but yeah, so this is one. The second thing that I wanted to quickly show you is a thing that I thought might be useful, and then we'll stop, and then I'll take questions, and we'll have a good discussion. Okay, so this is a nice way to visualize, where IoT is or where it's headed. Today, when we talk about IoT in the first, I would call it generation one, we're talking of sensors and how they're connected, the physical infrastructure, the hardware, the devices. The next step, and this is from, by the way, from McKinsey Global Institute Analysis. If you're interested, I'll send you the link. There's a nice report that you can read. It's free. The second phase is really, taking the hardware that we currently have and embed it with some very intelligent software, right? And couple it with analytics, build platforms. It could be an industrial platform, it could be a commercial thing, it could be an automotive platform, many things. And the single biggest, if you talk to any of the IoT experts today, and if you say, name one issue that you most worry about IoT, as you guys all know, they'll all say only one word: security, right? How do you build secure systems? That's a million, actually, I call it $1 trillion question, right? So that's something that you guys might want to focus on when you're building IoT. How do I build secure platforms? How do I build secure devices? How do I build secure software stacks? And the third one, which we talked about in the very first foil, is there is no point in putting all this hardware, software, analytics unless you're solving a real problem. It could be a smart city, for all you know, right? It need not always be an industrial problem. It could be a smart city. It could be a smart factory. It could be, a smart warehouse. If you look at all the Amazon warehouses, I mean, they're amazing, but they're all optimized for a particular business, case, right? So understanding the business, combining with technology, that would be the phase 3. So I hope this gives you some background, and I've tried to convey three key things. The biggest risk in IoT today is security. The real value for IoT is not just the hardware. That's just the starting point. The real value for IoT is somewhere else. How do you take all of that stuff and deliver a business thing? What's most valuable in IoT, which is not being monetized today, is the data. Right? People say, oh, is it Arduino? Is it Raspberry Pi? The first thing you should be asking is, what's the data that's being collected? Where is it stored? Is it in the cloud? Is it in what is called on-premises or on-prem? So those are some of the things that you do. And then, as you're just starting your journey, think of IoT as 3 pieces. The IoT is also called, by the way, today, cyber physical systems, right? So if you separate out the 2 words, cyber and physical, the cyber part is, all the stuff that happens, in the internet, but it's comprised of hardware, software, right? And the physical part is the real world. Where do you apply this? We talked about Predix platform from GE, which is a jet engine. Tesla is nothing but, a highly evolved IoT system. It's basically like a mobile phone with some wheels, right? And the third thing we said was very important. You take all this cyber physical stuff, combine it to provide business value. If you do that, you're way ahead of the curve, right? So with that introduction, I just want to pause, and no more slides, I promise you. And then we'll take some questions and go from there.
Very fascinating, short and sweet talk, sir. Thank you for that. Sir, my question firstly would be, as you said, data is one of the key things that people look for, right? Data enrichment, if I'm speaking precisely, right? How do you go about taking the basic, very raw data you have and turning it into wisdom or useful knowledge and applying it to solve problems? But I'm not able to think of any examples to connect this with.
Okay.
So
let me. build out. Let me give you one example that let me elaborate on one example that I just talked about in passing. So for all of you, right, what I'd like you to do right after this talk or whenever you get a chance this weekend, do look up Predix, Predix, right? That's the platform that GE put together. And let me just describe this to you in a minute. And what this thing does, how does data become valuable? That's the question that Kirit is asking, right? Okay, data collection is easy, but how do you use it for, digital transformation or business transformation? The way you do that is not at the data end. The way you do that is what GE asked the question: what are we selling these engines for? You might say, oh, it's a jet engine. Okay, great, jet engine is fine. But what do customers expect of that jet engine? So if I'm an airline company, right? If I'm United Airlines, Vistara, Air India, what am I optimizing it for? I'm not buying a jet engine. I'm buying a piece of machinery that helps keep my aircraft up in the air. And my goal is to, fly the longest routes, keep the planes flying as many times as possible in a given 24-hour period or in a 1 week period with as little downtime or maintenance time as possible, right? That's what I'm optimizing it for. I don't care if that engine looks round, square, comes with 19 blades or 190 blades. I don't care, right? I want reliability. I want performance, meaning it should be fuel efficient. So they started from the ulta. Right? They didn't say, oh, we'll build this, we'll do this data, we'll show you some nice dashboard. They went and talked to the airline industry execs and said, guys, what do you want? What do you want? So these guys gave them a bunch of things. And then when they boiled it all down, what they said is, look, these guys are not buying jet engine. What they're buying is reliability, they're buying performance, and their wish or desire is to optimize the operational cost of a jet engine. And then they said, okay, these are the kinds of data we must monitor, right? And these are the kind of things we must analyze. And this is the way we present this in the form of a dashboard, so that if I'm Delta Airlines and I'm looking at as an operational manager and I say, okay, hey, I've got my 787 and this thing has flown 200,000 miles and I think it's coming up for, and this is called predictive analytics, right? So this thing is, the software is basically saying, I think this thing needs maintenance in 45 days. So in 45 days, I'll make sure that anyway, there is some downtime. I will make sure that my plane doesn't get scheduled to fly on during that period when I can actually do a maintenance and things like that. So to short answer to your question is, as engineers, we think we know all the answers. We've collected all this data. I'm going to come up with some great analytical model and then present it to the customers. You actually want to do the opposite. Talk to the customers. For those of you who are new to design thinking, please understand the principles of design thinking. Design thinking has 5 key aspects, right? First is the empathy part, right? You need to understand what the customers really want, and that's the empathy stage, right? And then if you understand that well enough, then you can, you can define, you can ideate on possible solutions, then you define, and then you build a prototype, and then you essentially, test it, right? That's the 5 phases of design thinking. But short answer, talk to your customers, whoever it is. So let me give you a closer example. You're building an IoT system for PES University, right? That's your first project that you want to do this summer. So let's say it's a simple, camera monitoring thing that's there in the B block, so that it just counts the number of people who are entering the element block, which is the B block in PES. So one is to just be good engineers and just build everything and then go present it to, say, Professor Ajoy. He's the Chief Operational Officer of PES University. Say, hey, we built this wonderful IoT thing. It counts the number of people, recognizes maybe some of the folks, people who are not wearing badges. It highlights them. Then maybe there's a beep, or maybe automatically it says this person was not wearing, because you have the SRN, you can just say this, and you have a face recognition software. You can just say this person is not wearing a badge on this day, right? Instead, if you talk to Professor Ajoy in the beginning to say, what are some interesting insights you would be interested in? What is meaningful to you? And then you collect the right data, then you build the right analytics, can make a huge difference, right? So start with the customers, understand what their definition of value is, then use it to construct a very intelligent IoT and then deliver it back to them. Right? That I think is the short and long answer of it.
Yes, thank you, sir. Guys, you can go ahead and ask any questions that you may have.
Good evening, sir. Sir, you had mentioned a point on Agile Manifesto. Could you please elaborate more on that?
Yeah. So Agile Manifesto came about a couple of, I think, 2 decades ago. And the idea was that, things have gotten to be very complex. And therefore, if you just came up with this grand plan of, this is how we'll do, there are 5 stages, and just follow it. And that used to work for a very long time, right? I mean, if you study manufacturing, supply chain, manufacturing automation, or industrial automation, that's how things were worked. That's how things were planned. But as software got in, lots of things changed, and people said, "Hey, how do we?" For instance, what's the biggest difference between a hardware and a software product? Right? A hardware product, once it leaves the factory, I mean, it is what it is. This pen, after it left the factory, let's say, the cap is loose, nib is not working, or whatever it is. There's a gel pen, but whatever, the tip is not working. This is essentially, you have to throw it out. There's no such thing as maintenance per se. Right? With software, you can release all kinds of patches even after you've delivered the software to the customer and somebody files a bug. So this whole thing called for a different way of doing it. And Agile basically said, do this in an iterative way. Right? Instead of, say, if this is the amount of work to be done, chop it into smaller pieces, take each piece at a time, and work with the customer, figuring out what they want, deliver every 2 weeks, and that's called a scrum, 2 to 4 weeks. Most companies do it at a 2-week level. Deliver actually a mini version of the product to the customer, get the feedback from the customer, and if something needs to be changed, you iterate it. You don't wait for the entire thing to be built, give it to the customer, and the customer says, this is not even the thing I was looking for here, right? So you take a project, chop it into intelligent parts. You work in smaller, what are called scrum cycles, and you work with the customer to deliver actually some value at intermediate points. And then you do this in an iterative way, meaning, you don't just go from linear, from left to right, A to B, and say this product is done. You build it in an iterative way, so the quality goes up, the time to develop it goes down, the value you're developing for the customer goes up incrementally, goes up dramatically higher. So if you just type Agile method or Agile Manifesto, the first thing you might want to do is look up some YouTube, then go to the agilemanifesto.org and start to understand what is this philosophy. We just did a talk about a month ago. We called software Scrum, Agile Black Belt, Mr. Narahari from TCS. It was a wonderful talk that was given about last month, because it's super important to understand how to build a product, whether it's IoT, cloud, big data, AR, VR, doesn't matter, but it's the mindset of breaking a problem into smaller pieces, organizing the team in a very different way. It's called a Scrum team, and then working with the customers from day one. Right? It's not like, oh, I'll build this whole pen and then give it to you, and then you can check and write. No, when I have my nib ready, I can just give it to somebody and say, put it to a wooden stick and say, just dip it in the sink and just write. Do you like the feel of it? And then say, oh, you didn't like that? Okay, I think we can change the point. We can change the ink flow mechanism. We can change the ink or the gel. So all these things kind of go, and there's enough TED Talks. I'd highly welcome you to take a look at it. And at some point, I will be happy to invite Mr. Black Belt he's a certified Scrum Master. We can get him to come and give a talk, and he does it in a very nice way. There's a interactive, hands-on workshop that he does. Folks, it is 6 o'clock.
Yes, sir.
It's 4:2, but I have a class that I need to run. And so I wish you very well in your journey, not just IoT, but your stay at PES. Look forward to seeing you, and I think go have a wonderful time. I know these times are very challenging, but as they say, when the going gets tough, the tough get going, right? So be well, be safe, and enjoy the ride.
Thank you, sir. Wonderful work.
Thank you, sir.
All right, guys. See you. Bye.
Okay, guys. Thank you to Professor Satyaprasad for that amazing talk. We'll be continuing with the workshop with a hands-on session, more importantly. So the first session is getting started with Proteus 8 Professional, right? So I'll be handling the very first event, which is interfacing Arduino Uno with an LED and linking it. All right. Go ahead and open up Proteus. Right. I will wait for every single one of you to open up Proteus before I proceed. All right. Isha can let me know when everybody reacts with their raising their hands.
Guys, once open your ID, please raise your hand. So guys, today's event will be split into 4 sessions. Firstly, we'll be familiarizing this you guys with Proteus. In the second session, we'll build an app using MIT App Inventor and build a circuit on Proteus. The third part will be dealing with IFTTT applets, and the fourth one will be an introduction to ESP8266. Guys, have you all opened up Proteus? Participants, please raise your hand once you're done with it. And guys, a quick word of caution, right click on the Proteus icon and run it as administrator. Otherwise, your Arduino libraries will not load up. Okay.
Okay, we have 4 guys. Isha, could you confirm if that number of participants are present as well?
There are a couple of participants. I think they're probably opening up the ID. We'll wait for another minute.
Yeah. Meanwhile, guys, though that was a brief session, I believe it is a very interesting session, very interesting talk given by Satyaprasad sir. Due to his lapse of time and his class, I believe he could not deliver a longer talk and have a more interactive session. And I highly appreciate you guys joining in, even though your ESAs are going on. So let's get this done as soon as possible, so you guys can go back to your studies and having learned something over the course of the next 1.5 hour to 2 hours, right? So Isha, has everyone raised their hands?
Yeah, around 6 of them have raised their hand. I think we can proceed. Probably the others are still opening their ID. And guys, the meeting is being recorded. So in case if you all miss any, part of it, you can always go to the Teams chat and rewatch the part you missed. Okay.
Moreover, guys, we have pre-recorded demos of the entire thing. So every one session, or whether it is my demonstration or whether it is going to be the next demonstration in line or the next for the continuing end of the workshop, everything is pre-recorded. And we kept in mind that, given that we were all working from home and this is a completely online workshop, some of us may face internet issues. So we have kept the pre-recorded sessions in handy, which will be made available to you at the end as well. And if any internet issues arise among the presenters, we will go ahead with displaying the recorded session. All right, guys. So I'll go ahead and get started. So open Proteus, and on the window to the top left, you should be able to see ISS in blue, which is a schematic capture. Click on it, and it should open up the schematic. Yeah, guys. So the window is open. So you may change. You may hit G, which is a shortcut key to change the grid lines. I'm comfortable with a completely empty grid. You may go ahead with whatever you want. It does in no matter or in no way affects the performance in any kind. All right. So what we're going to be doing is we're going to be simulating the Arduino with the and blinking an LED related, right? So we'll go ahead and list down the parts. Firstly, we need the Arduino Uno, we need a resistor, and we need the red LED, right? So how you add
the only one, but I can't see what you're displaying. Like it's on the home page. Is that just me?
Guys, he's using another version of Proteus. So the one we sent on the group, it'll directly open up to this page without the ISIS part. The versions are varying slightly, so you guys can just follow what he's telling. Don't follow the part where he told ISIS. You won't find that symbol in the version I've sent. So just click on it and start off by typing out a new project name and hit next till you reach the blank screen. Okay. And guys, towards the end of each session, we'll have a small doubt clarification session. So in case you guys want to clarify your doubts, please put it up on the chat and we'll make sure it gets addressed. Okay.
Okay, so we have to click new project.
Yes.
Yeah.
Kiriti, your screen is frozen, bro.
Oh, no. I'm not doing anything as of now.
Okay.
Just hit a new project for the name of the project and click on next, like how Kiriti will show now.
Okay, guys. So I hope you have opened new projects and given it appropriate names. So as I said earlier, we have three main components that come into play, or three main devices that we'll have to add on to the grid in the schematic, which is the Arduino Uno, a resistor, and the LED. So how do we go about adding devices to simulate in Proteus? Is we click on go over to the left side and double click on devices, right? And then it's going to open up this overlay. So the first component that we'll be adding is Arduino. So type in Arduino and you will get the Arduino Uno. Select it. Click on OK.
I can't see what you're doing right now, actually.
All right, is none
Kiriti,
of it visible at all? Yeah, give me
it's
one
frozen.
second. Give me 1 second. I'll just try to reshare. Yeah, is it visible now, guys?
Yeah. Could you go over what you just did?
Yeah, just double click on devices to the left here.
After creating a new project.
Yeah, devices to the left, right? Once you open up devices, enter Arduino in the keyword section and select Arduino Uno, right? After selecting it, you're going to go over to the bottom right and click on OK. Now you're still not going to get it, as in you have to confirm the selection, right? The pencil emoji indicates that you have to confirm the selection. So left click once and the Arduino Uno sketch will come on board, right? And to place it, you're going to have to left click again to confirm. And we have the Arduino board. Next, we're going to repeat the same process for adding a resistor and LED, all right? So you're going to go to devices, double click on devices, the overlay opens up, right? Type in resistor. One device is going to show up. We're going to select it. Come on down to OK. Hit OK. Then confirm your selection while clicking left and place it, right? Similarly, you're going to again hit on devices, double click, type in LED hyphen red under keywords. Then you would select it, click on OK. Left click once to confirm selection and left click again to place it, right? Now, for better understanding, you could just right click on it and rotate it anti-clockwise, right? So everything is in order. And you could just hold and drag to move. Now, the missing terminal is the ground terminal, which should be connected to the short end of the cathode, of the diode, right? So you're going to right click on an empty space in the schematic, and you're going to hover over place, move to terminal, and then you're going to click on ground. I hope you guys are following along. If not, just stop me and I will repeat the entire process again, right? So click on ground and place the ground terminal here. Now we're going to complete the connections, right? So you're going to go to the 12th terminal of the Arduino. If it's not visible, right? So the 12th terminal of the Arduino, click on it, connect it to the resistor. Click on the other end of the resistor, connect it to the diode. Short end of the diode to the ground terminal, right? I hope this has been done so far and you guys are following along. If so, I'll go ahead with the Arduino part. So open up your Arduino IDs, guys. Yeah, Isha, could you just tell me if everyone's raised their hand to indicate that they've opened up the Arduino IDs?
Sure. Guys, if you have followed the part till here, please raise your hand.
I have a question. Like right now, I went to ground and then it says terminals instead of devices, right? How do I go back to devices?
Oh no, that's just fine. Like you click on the Arduino again. Don't worry about that for now. Like
No, I didn't.
you're gonna have to clear selection. You didn't add the ground terminal, is it?
No, I didn't add the resistor, so I need to go back to devices.
Oh, you didn't add the resistor. All right.
Yeah.
So you're going to go over to the left side. You're going to go to component mode, right? You see component mode in this toolbar navigation bar over here
Right.
to the left side. Yeah, component mode.
Yeah, cool, man. Thanks.
Yeah. Oh, so did you get it?
Yeah. What's the exact keyword for the resistor?
Resistor. Just type in resistor.
I'm actually getting a lot of stuff.
You're getting a lot of stuff? I don't know. When I type in resistor, it shows up only as one. Oh, library ASIM MDLS, analog resistor primitive.
I'll look for that one then.
Let me know when you get it, all right?
Yep, I got it.
Yeah, so just place it and do the connections.
Yep.
Is everyone following along so far?
Guys, can you please raise your hand if you all are done?
Yeah, you guys can go ahead and unmute. I mean, we aren't going to eat you or anything. So it's completely fine. Feel free.
Or if you're shy, you can type in yes in the chat box so that we know that you guys.
Yeah, so I hope you guys have placed the resistor, the diode, and the ground terminal and have made all the connections, right? If not, just stop me or else I'll continue. Okay, so no one's stopping me. So I guess I'm good to know.
Three of them are
good to go. So yeah, okay. So I guess no one's stopping me. So I guess it's fine. Right click on the resistor. See, the important part over here is that 10K is too high of a resistance value to pass even a small or good enough current or power supply to the LED to switch it on, right? So what you're going to do is you're going to double click on the resistor, and under resistance ohms value field, you're going to change it to 300, which should be small enough to give a sufficient power supply to the LED, right? And you're going to click on OK. And your changes are going to be saved. Now open up your Arduino code, Arduino ID. Okay, so I'll put up this code in the chat. If you guys haven't downloaded the code, the INO file from resources folder that was given. So you can directly copy paste this. Yep, it's sent. So just copy paste the code that I have sent right now on the chat. And I'll give you a brief explanation about it. Yeah, guys. So continuing with the explanation. So since it would be easier and more accessible to refer to the 12th pin, since we know we're going to be giving the output through the 12th pin, we're going to be calling it LED now, assigning the variable LED number 12 to the variable LED. And void setup, for those of you that are new to the Arduino, and if you haven't gone to the Arduino manual that we've provided. So void setup contains a set of statements that is used to, indicate what pin would be used in what mode. For example, we're going to set the pin mode here to output state, right? So the 12th pin will be used to deliver power outside, right? And not receive input. So output is going to, the Arduino board is going to send any output signal, either high or low, digitally, through the 12th pin from now on. Next comes the void loop function, which contains a set of statements that are consecutively and continuously executed until the power supply or an interrupt is reached, right? Until the power supply is cut off or an interrupt is reached. Going over the statements in void loop, digital write, since you can either only have two signals, which is high or low, 0 and 1. So what we're going to be doing is we're going to first switch on the LED. We're going to wait for half a second, and then we're going to switch off the LED, and then we're going to wait for another half a second before repeating this entire process, right? So in essence, this is what the code stands for. Digital write, LED, high, sends a high signal, indicates the Arduino board to send a high signal to the 12th pin. Then we're going to wait for half a second, and then digital write LED low is going to cut off the power supply to the 12th pin from the board. And then we're going to wait for another half a second before this entire set of statements is repeated. Right, guys. So once you're done copying this code, and if you have understood the code or not, let me know if stop me again. So save this file. After saving the file, what you're going to do, this is a very crucial step and will be required for the rest of the workshop as well. So please remember, please do it right now, follow me. So click on File, go down to Preferences. All right, guys, I hope you guys are following this. Click on File, go down to Preferences, hit it, and then you're going to have to see show verbose output during compilation, right? Compilation should be checked. You should check the box compilation and leave it checked. And then you're going to click OK. All right, guys, hope you all are with me so far. So after saving the Arduino file, what you're going to do is you're going to click on Verify. All right, and then the compilation process begins. So essentially what you have done right now by ticking the compilation box is similar to what you would do when you're entering GCC-O or GCC-C in your Linux terminal at campus that you're learning using at lab, right? So you would be getting the entire compilation process being shown, and you'd be able to get an address or the access to the object file that is created. So in the case of Arduino, it creates the object file created in Arduino is a .hex file. It ends with a .hex. So once the compilation process is done, you're going to head over to the second line that begins with C:// right? So so you see the second line, and you're going to follow it to the very end, and you're going to see that it ends with .ino.hex, right? Now what you're going to do is you're going to copy this path till the nearest C:// right? You're going to select it and you're going to hit Control-C to copy it. Then you're going to come back to your Proteus.
I
Right?
can't see exactly what you selected. I think your screen is frozen again.
Yeah, can you see it right now?
I can't, but I'm not sure if that's just me.
Kirti, can you please rejoin? I think it's frozen.
Yeah, I'll just stop streaming. Yeah. Yeah, Yeah, is it visible now? Yeah, so I selected this. Are you able to see what I've highlighted?
No, it hasn't come yet.
Okay, give me a
You
second.
can see the blink sketch. Re-highlight the hex file, no? The entire path.
Yeah, I've highlighted it now.
No, Casey, it's not visible.
Oh, not yet? All right, then I guess I'll just send a screenshot of it on the chat. Give me just a second, guys.
But like if it's frozen, we can't see what you're gonna do next either, right?
Uh,
The file looks like, more or less how the path looks like. You can probably scroll down in that terminal and see your hex file. Okay. Kirti, can you put it on chat? Maybe.
yeah, I've put it up on chat. So the
Okay.
image has been sent on chat. I hope it's visible to you guys.
Guys, are you able to follow?
Guys? Yeah, so if you have gone through the image and you're able to see, right, I'll continue with the process. So head back over to your Proteus sketch after copying that path. So if you have the path copied and ready, Control C and have it ready in the clipper. So what you're going to do is head back over to your Proteus. All right. So once you head back over to Proteus, you're going to double click on the Arduino board that you have set on the schematic, right? You're going to double click on the.
Sorry for interrupting, but your screen has frozen again.
Okay. I guess I'll just share the specific application window. Yeah, I'll share only the application window. Yeah, so is it visible now?
Yeah.
Much better, huh?
Yeah.
Yeah, so once you've copied the code, double click on your Arduino and it's going to open up an overlay, right? So do you see this program file field? You're going to paste whatever path that you copied in it. Image. Okay. So you're going to paste the entire path of the .x file that you copied earlier, and then you're going to click on OK. Guys, following me? So once you click on OK, your schematic is ready to simulate. At this point, everything is ready. So you're just going to go down to the bottom left and then click on Run the simulation, right? And your LED should blink. Switch on, switch off, switch on, switch off, right? With half a second delay. Is that visible for you guys? Is that happening?
Yep.
Yep. So this was just to get you guys accustomed to using Proteus and the Arduino IDE. That's it from me. The first segment of the first session has ended here. I'll stop sharing. Yeah, my sharing has stopped. So yeah, we have the next session with the next part of the session, which is interfacing Arduino Uno with an ultrasonic sensor, which will be done again using Proteus and Arduino IDE. So Prateek, go ahead.
Yeah, hello guys, I'm Prateek, and I belong to CODS IoT core team at EC campus. So I'll be teaching how to interface Arduino with the ultrasonic sensor. So let me share the screen. So are you people able to see the screen?
Yep.
So first, when you open Proteus, okay, just save the previous sketch, whatever you have done. And then, and once you save it, click on this icon, just select everything and remove it. Let us do another sketch. So did everyone finish?
Guys, I will open up a new sketch. Are you on pace with him?
Yep.
If you please raise your hand. Cool. Pratik,
Yeah.
I will continue.
Yeah, so the things that we need for our project is the Arduino Uno, the ultrasonic sensor, and since this is a sensor what we are doing, what we are taking here, so we need a special element called POT-HG which helps us in sensing, and then we need a virtual terminal also. So first go to this section and click on the P icon. So type Arduino Uno. Select this board. It will be in this section. Now, as I said, we need an ultrasonic sensor. So first, did everyone like put the libraries what we gave in the resource section into the libraries of the Proteus? Else, I don't think so. You'll get the ultrasonic library. Did everyone do it?
Yeah.
Okay, so we'll move on. Type ultrasonic sensor and click on this one. It will be loaded here. And now we need a sensing element, as I said. So type POT HG. So again, choose it. And so we have the 3 devices. Other devices are already available. So let us come out of this. Click on the Arduino Uno R3. Place it here. Right click and rotate clockwise. Now let us choose the ultrasonic sensor. And place it here. According to our sketch, okay, so the trigger pin is connected to the 3rd pin of the Arduino and the echo pin is connected to the 2nd pin of the Arduino. Okay, so let us make those connections first. Now we need a sensing element for this sonar sensor or ultrasonic sensor. So click on POT HG and place it here. So make a connection between the test pin to this terminal of the potentiometer. Okay, so we have done the minor connections. Now what we have to do is we have to give a 5-volt supply because our ultrasonic sensor only works on 5-volt supply. It doesn't work on any other supply. If you give any other supply, then the distance measured by the sensor won't be correct. So we need a 5-volt supply only. So go to this section or the generator mode, and DC is highlighted. So just come here and click, connect this pin to the DC terminal. And now, since it works only on 5 volts, double click on this and set it as 5 volts. So we also need a ground terminal. So right click, go to place, terminal and ground. So you get a ground terminal and connect it here. Now,
could you go through how you got the DC?
The ground terminal.
No, the
Which,
previous.
the DC thing. Oh, okay.
Yeah.
So here there is a generator mode, right?
Oh, right. Yeah.
Yeah, their first thing is only the DC generator. Okay, just click on that and place it here.
Yeah, cool.
So
And
now
then the ground.
yeah, and then the ground, just right click, go to place,
Oh, right.
and here you get a terminal and go to ground.
Cool.
So now what we need is a virtual terminal, because we are not using a specific part such as a LCD to display our distance. So we need a special terminal. So go to this part, click on this, you get something called as a virtual terminal. So click on the virtual terminal and place it here. And this virtual terminal works on UART protocol, where once it transmits from the virtual terminal to the transmitter port of the Arduino. So let us first connect those two. And now let us, since we need the Arduino to receive the message that the values are getting displayed. So we are going to connect the transmitter part of this to the RxD part. So with this, our whole connections is complete. Now we have to check if the correct hex file is loaded onto the ultrasonic sensor, which was there in that set of resources. So we have to double click on this, and then we have to go to folder. Actually, the correct library won't be loaded. So go to Windows C, then go to Program Files 86, where you get Lab Center Electronics, Proteus 8 Professional, binary file. So we got our ultrasonic tep.hex. So double click and say OK. So now our complete thing is done. So 1 minute, I'll be sharing my Arduino screen. So can you see my Arduino screen? Hello, can you see my Arduino screen? Yeah. So what have we done? The trigger pin we have connected to the third terminal of the Arduino, and echo pin to the second terminal of the Arduino. We need two more variables. One variable is called duration and the other variable is called distance. Okay. So the ultrasonic sensor works on the principle that when you give a pulse to the trigger pin, okay, the pulse what we are giving from the Arduino is 10 microseconds pulse. Okay, the width of the pulse is 10 microseconds. Okay, so what is this sensor doing? The sensor is generating a sound wave. What type of sound wave? Ultrasonic sound wave. Okay, so that is actually at 40 kilohertz, and 8 such signals are sent by this ultrasonic sensor. Now, if it encounters an object, the waves are going to get reflected back, okay, to the another pin called the echo pin. So there is a time delay between the sent signal and the received signal, which is sensed by our echo pin. Okay, so the main thing to calculate duration is the echo pin, because the sensing is happening between the trigger pin and the echo pin. Okay, so that we have shown it here. Duration is equal to pulse in echo pin and high. Okay, this high is to set the whole sensor into the highest state, means the output state. Okay, so now we have to calculate the distance. Okay, the speed of sound in air, let us take it as 340 meters per second. Now we have to convert that 340 meters per second into like centimeters, because the ultrasonic sensor what we are using, it is usually measured in centimeters. Okay, and the maximum range is 450 centimeters. So we are going to convert the 340 meters per second into centimeters per microsecond, because our width of the pulse given is in microseconds. So it comes around 0.034. Since we are covering twice the distance, one is sent and one is received, so we are going to divide by 2. So distance is equal to duration star 0.034 divided by 2. That is how we are going to calculate the distance. Now let us go to the file, go to preferences, and okay, there is some problem here. Okay, like Kiriti said, like you have to go to the preferences, and in the preferences add verbose output. It should be checked as compilation, else you won't get the hex files. Okay, so actually that is not shown. Now just compile the program. I think you have the program with you.
What is the file that we have to add to the ultrasonic? Is it the .hex file?
Yeah, no, not the bin where, in which.
The one in the bin.
Yeah, the .hex file. It will be written like ultrasonic step or something.
Yeah.
So you have to add that hex file. So our compilation is complete, and we should move on to the place we get our hex file. So can you see the hex file over here? The ultrasonic.iono.hex. Okay, I'll highlight it. Are you able to see the highlighting?
Yep.
So just copy that. And 1 minute, I'll change my screen sharing.
What's the name of the code, the Arduino one?
The ultrasonic.iono.
IN.
INO. Ultrasonic.ino.
Where was that?
It should be there in that resources section where we have put codes, and in that it must be there in the Arduino folder.
Could you just copy paste and send the code on the chat?
On the chat. Okay.
Yeah.
Yeah.
Thanks.
Hey, it's located in the code section, and then you need to go to ultrasonic sensor. In that, you will find the ultrasonic.ino file. In case you want to know where it is.
Okay, cool.
I've sent it on the chat.
Yep, got it.
So we come back to our original schematic capture, where we have to double click on the Arduino and paste our hex file over here and say OK. And now we have to simulate it. So we'll simulate it. Okay, let us check if the ultrasonic sensor file is correct or something. Yep, this is correct. And let me check if my Arduino thing is correct. So let us double click and so let us paste the thing and say OK. And now let us simulate. Okay, so you're going to get all the distances like this, one by one. Okay, and we have this potentiometer, right? So this potentiometer, okay, it has the highest value and the lowest value. Highest value will give you higher the distance. Lowest value will give you the lower the distance. Okay, so I can say that my distance is directly proportional to the resistance of the potentiometer. So that is how this whole simulation works. So let me so if I increase, see, it is increasing the distance between the ultrasonic sensor and the object. Similarly, if I try to decrease, so it starts decreasing on its own. Okay, so this is how your complete ultrasonic sensor working. Okay, so this is only about our whole setup. Does anyone have doubts or something? I'm going to stop the simulation.
Did you change anything in the code? Because I'm getting some errors when I try to simulate it.
Just send the errors on the chat.
Okay.
I'll see.
Or if you want, you can share the screen.
Yeah.
Sure,
Stop
I
sharing.
can do that too. Can you see it?
Yeah, you have done compiling.
This is what I'm getting.
Okay, just show your schematic capture. Have you set the voltage?
Yeah. 5 volts.
Yeah, okay. So have you loaded the hex file onto this thing on the ultrasonic sensor?
Yep.
Yep, okay. Just click OK. Just go on to the code 1 minute.
Yeah.
Just go on to the code. Just come down.
I'm just gonna try recopying the.
Yeah.
Rerunning.
Just check if you have copied the correct hex file.
It's
It
this
will be
one.
at the end. Yeah, that one. Don't include the double quotes.
This one, right?
Yeah, correct. Double click and say
I think your ultrasonic hex file was not right. Can you please reselect it?
Sure. Is this one, right?
Yeah, that one.
Try going to
No.
this PC, see program files, Lab Center Electronics.
Oh no,
then
I downloaded it on downloads.
Don't use that. Maybe that file is not working. Try doing it the longer way. Maybe that will help you sort out things.
No. I changed the path to.
No, your path of installation will remain the same. Don't worry.
No, I changed the path of installation itself.
Okay, so wherever you've downloaded Proteus, you need to go there. It'll be saved in the folder Lab Center called Lab Center Electronics.
It's this one, right?
No, that is the zip file. Okay, wait. Yeah, it's that. The first one. Yeah.
Yeah.
It should be in
Then bin.
the bin.
Mm-hmm.
Just try to put the file in the bin.
Okay, 1 second. Why can't I open anything? Oh. Still same error.
You can do one thing, go to debug,
Okay.
go to schematic capture,
Yeah.
go to debug,
Mm-hmm.
reset debug pop-up windows. Yes. Then start run the simulation once again. Okay, you can do one thing. You drop in your email ID. We will get back to you within a day and sort out this error. Okay?
Yeah, sure. I don't want to interrupt the class.
Yeah, fine. We'll get back to you for sure. Just drop in your email. We'll get back to you within a day. Okay?
Yeah, sure. I'll do that. Thanks.
So now I think the next person will take over.
Yeah. So now that you guys have simulated 2 basic circuits, in the presentation we're going to send you the presentation after the workshop. In that we've included another circuit wherein we're interfacing the Arduino Uno, an LCD, and a real-time clock. Okay, so you guys can go through the video and let us know if you have any queries. Now moving over to the doubt clarification session. Anybody has any other doubts?
The virtual terminal I just added, like I didn't do anything with that. Like there was nothing to do, right?
There's nothing to do. You just connect the RX of that to the TX of the Arduino, and the TX of this to the RX of that.
Yeah. Okay. Cool. I did that.
That's it. No other hex file or any other thing of that sort.
Cool.
Fine. Now, any other doubts? Anyone else with any other doubts? Okay. Guys, if you have any doubts, you can mail any of us after the workshop also, it's fine. We'll now move over to session 2, wherein we're going to build a weather monitoring station using Proteus and MIT App Inventor. I will be sharing my screen now, and my fellow core team member, Akshay, will be showing you how to build the app from scratch. Before that, make sure that you have the MIT AI2 companion app installed on your cell phones, and create an account on MIT App Inventor. I'll probably send you Akshay will send you the website. Meanwhile, I'll show you how to simulate the sketch on Proteus. So is my screen visible?
Yep.
Cool. So firstly, we will need an Arduino Uno, a DHT11 temperature sensor, a Bluetooth module, and a virtual terminal. Okay, let's begin by clicking on devices, then search for Arduino Uno, hit enter, it's here, double tap. Then we need a Bluetooth module, so search for Bluetooth. select HC05 here, double tap, then move over to DHT11, that is basically your temperature sensor. You'll find it here, double tap. So now we've included most of our components. Click on close. Have you all followed till here?
Yep.
Cool. Then we need to select Arduino Uno. Then to place it here, double tap. Then click on Bluetooth HC05. To place it here, double tap. Click on DHT11. Then double tap. And to visualize it, we need a virtual terminal. So head over to Instruments. It's here. Then click on Virtual Terminal. And then double tap. Fine. Now you can rotate this by, you can rotate this clockwise and reposition it so that it's easier to understand. So basically in the Arduino sketch, we are assigning pin number 8 as RX and 9 as TX. Now what you need to do is you need to connect the TX of the Bluetooth to the RX of the Arduino and the RX of Bluetooth to the TX of Arduino. So TX of, so pin number 8 is RX and that is going to be connected to TX of Bluetooth, and pin number 9 is TX and it's going to be connected to RX of Bluetooth. Have you all followed till here?
Yep.
Cool. Now the virtual terminal, RX goes to TX and TX goes to RX. Have you all followed? Have you all followed till here?
Yep.
Cool. Now let me reposition this. Now you need to add power and ground supplies to the DHT11 sensor. So right click, place, terminal, power. Place it somewhere here. Then again, to add ground, right click, place, terminal, ground. Place it here. Then you connect this pin VDD to power and ground to ground. Now in the Arduino sketch, we've defined pin number 2 as the DHT11 pin. So connect this data pin to pin number 2. That's it here. Now let's move over to the Arduino sketch. I will reshare my screen. So guys, this is the code for weather station. So firstly, we will be defining the software serial.h library. Why are we doing so? Because we need to use some other digital pins of the Arduino as TX and RX. So by default, we use pin number 01 as TX and RX. So in this case, it's already been occupied by the virtual terminal. So we need to define 2 other pins as TX and RX. So we've defined pin number 8 as RX and 9 as TX. So we make use of this library to do that. Here we include DHT.h library. This library is not built in, so you have to install it. So for that, you need to go to Sketch, Include Library, Manage Libraries. It's going to take some time depending on your internet connection. So have you all followed till here?
Yeah, could you send the code again on the chat?
Okay, sure. Meanwhile,
I have sent the code actually in the chat.
okay, one of
the
the
chat.
have sent it to you.
Oh, cool, thanks.
Okay, so here you search for DHT. So you need to install this library, DHT sensor library by Adafruit. I've already installed it. You will get an option called install. So you need to install this library. Once you're done installing that, this might take some time. So Once you're done with that, you need to include the library here. Okay. You have the code, right? Every one of you?
Yep.
Cool. So once you're done installing the library, please include this header file. If you do not include it, this code will not work. Now, you're attaching the DHT11 to pin number 2 of the Arduino. Hence, I'm defining the pin as 2 here. And we have two varieties of DHT. One is the DHT11 and the other is the DHT22. So in our case, we are using a DHT11. So you need to define the type as well. Okay, so in DHT type, we define it as DHT11. Here we are creating a DHT object, assigning the pin number to it and the type. Okay, and now coming to the setup part, we are going to start communication at 9600 baud rate. Then we're going to start the Bluetooth object and the DHT object. Now let's head over to loop. We are going to record humidity and temperature values as it's a weather station. So we're going to, this function will read humidity and this one reads temperature. So in the humid and temperature variables, we store humidity and temperature respectively. We need these few lines to print it on the virtual terminal. So this will print humidity and this will print humidity value, this will print temperature and this will print the temperature value. These 4 lines are essential for us because we're going to use this in the app. So I'm going to pass temperature and humidity values separated by commas so that it can be distinguished in the app. Okay. So once this is done, make sure that you go to File, Preferences, make sure that compilation is checked again. Hit on OK and click Verify. Have you all followed till here?
Yep.
Cool. Give me a minute. Yeah. So the compilation is done. Move a little to the left, sorry, right, and head a little on top. You will find the hex file somewhere towards the corner. This is the hex file I'm talking about. You need to copy the hex file. Copy it. And I will show you the other part on Proteus. Give me a minute, I'll share my screen. Okay, so now you need to double click on the Arduino, paste the hex file, hit OK. Have you all done till here?
Yep.
Then hit on play button. You're getting humidity and temperature values here. That means your code has worked properly. Is everybody getting values on the virtual terminal?
Okay, yeah, this one's working.
Cool. Now we need to build an app out of it, right? So we've made use of a Bluetooth module here. So what you need to do is, firstly, you should make sure that one second, I'll just pause stop the simulation. You need to connect your laptop to your mobile Bluetooth. Okay, just make sure your both the Bluetooth settings are turned on and they're paired and they're connected. Okay, once you're done with that, we have to double click on Bluetooth SC05. The reason we are doing this Bluetooth pairing is because the app needs you to enable Bluetooth and pair it up with your laptop. Okay, so have you all opened up the edit component part? I mean, have you all double clicked on the Bluetooth module?
Could you hold on for a second just so you can connect the Bluetooth?
Okay, sure. Okay, guys, even if that part is not getting connected now, it's fine. We'll do that later on after we're done with the app. Okay. So as of now, come back to this. Double click on Bluetooth. Select your COM port. In my case, my COM port is 4. You guys might not know your COM port, so I'll show you how to figure it out. You need to click on Bluetooth. Open your Bluetooth settings. Then go to more Bluetooth options. Make sure that the discovery checkbox is checked. Then you go to COM port. You will have a list of COM ports.
Since you've shared this screen, we can't see the Bluetooth thing.
Oh, sorry. Sorry. Give me a minute. Wait. Can you see the Bluetooth settings screen?
Yeah.
So to get that, you need to click on Bluetooth settings, or open the settings of Bluetooth, and on the right hand side, you will get more Bluetooth options. If you are not able to follow this, I will I'll put in a video link. You guys can watch that and verify. Okay, so you guys can see that you have options, COM port, and hardware, right?
This is Bluetooth settings of your laptop.
Yeah, of my laptop. Yes.
Okay.
Have you all reached here?
Not exactly.
Give me a minute. Or go to the search bar and click and just type out Bluetooth and other device settings.
Yep, I'm there.
Okay, right corner, more Bluetooth option. Right under related settings, you'll have something.
I'm not there.
Are you at Bluetooth and other devices?
Yeah, Windows 10.
Yes. More Bluetooth options. Are you not able to find that? It's on the right hand side under display settings.
Oh, yeah, I found it.
Click on that. That will open up to this. Make sure that the discovery checkbox is checked. Then, are you all done with this part?
Yeah.
Then go to COM port. In your COM port, you will have a couple of incoming ports and a couple of outgoing ports. You need to select one of the incoming ports. In my case, COM4 is incoming, so I have used that and put it in the physical port of my Bluetooth module, if you all remember. I will reshare my screen.
I see nothing on my COM ports.
See, maybe you'll have to do. Okay, guys, maybe you'll have to, do a little bit of step. Get back to you guys with another video. Please.
I believe Manasa has some issue. Manasa, could you just unmute and express your issue?
I too do not have any COM ports.
Yeah, you can click on add.
Okay, fine.
Yeah, click on add and you can get the COM ports. Cool. Did you get it?
Okay, yeah, guys. So let me just clarify what's going on right now. So Windows has these series of legacy ports that aren't necessarily native to Windows 10, but have come from the previous OS system versions, right? So legacy ports are something that you have to add personally, or something that gets added the first time you plug in your Arduino, right? Given that this isn't an offline session, and the moment you plugged in your Arduino, you would be able to see a COM port. You'd have to manually add a COM port on your Bluetooth, right, on your device, which is what Akshay is indicating.
Yeah, I was
So
able to add COM6.
yeah, you were able to add, right? Perfect, perfect. And it's showing up as incoming, right?
Yeah.
Yeah, perfect. Manasa, is it working for you?
Yep, got it.
Got it, right? Anyone else? Charita, is it working for you? Isha, I believe you can proceed.
Yeah, cool. So once you have selected the COM port, 1 second, I'll reshare my screen. I believe I've stopped sharing. Go back to Sketch. Click on OK. Oh, wait. 1 sec. Hit OK. And that's it. This part is done. Now we'll start building the app. Okay. The app part will be handled by Akshay. Akshay, you may please take over. I will stop sharing.
Yeah, thank you, Isha. So now since we have seen the simulation in Proteus, we can proceed with building the app for it. Okay. Is my screen visible?
Yeah.
Yeah, okay. So have you created your account in the MIT App Inventor?
Yep.
Cool. Okay. So yeah, so do you see the screen over here? Just a second. Yeah. So are you in the screen?
Yep.
Yeah. So you can start your new project. So you can keep the project name and you can open it. Fine.
Yep.
Cool. Okay, so basically MIT App Inventor is a user-friendly tool with which you can design apps by just dragging and dropping the UI elements, and you can code it in blocks. Fine. So what you can do is, so this is the screen one. So you can set the alignment over here and let us create a empty label. So you can name it as connect to Bluetooth. Yeah. So this is just a text, fine, and you can customize it however you want. So this is just a label, and now we are going to select a list picker. So this list picker is basically like a drop down menu. So you can use this to display the available Bluetooth connections available. So in the sense it can be used to connect to Bluetooth. So you can place it over here and you can add
Could
a
you go
text.
over that again?
Yeah, sure. 1 second. Yeah. So do you see the list picker over here?
Yeah.
Yeah. So it is basically like a drop down menu. Fine. So it basically shows the list of elements which are available connections for Bluetooth. So yeah. So now you come down to connectivity. Fine. You can add the Bluetooth client. This is basically indicating that the app needs to connect to Bluetooth. So are you following till here?
Yep. How do you make them center aligned?
Okay, so you select screen, fine,
Mhm.
and align
Oh,
horizontal.
cool.
Yeah, got it right. Fine. Now you can see, you come to layout tab, fine. You add a vertical arrangement over here. And then make the height and width to fill parent. So it basically occupies the full screen. Yeah, tell me once you're done with it.
Yep.
Cool. So now here again you can set the alignment. So let us keep both at the center. Fine. So you're going to create another empty label and it will have the text as temperature. Fine. So you give it some font size, customize it. Yeah. Did you do this part?
Yep.
And copy paste it. Copy that block, Control C, Control V, and rename it as humidity. And you can align it to center, like text alignment. Fine. And now we need some text field to display the values, right? Which we are receiving from the Bluetooth. So you can add 2 more empty labels. Name it as. So these are basically like naming the variables. Are you done with creating these 2 blocks? You can place it between them. Yeah. So for now, let us give it as 2 dashes or 2 hyphens and customize the font of the numbers. Fine. Okay. So yeah. So you can, yeah, so you can try out variety of stuff for customization. And so yeah, have you completed till here now?
Yep.
Okay, cool. And now we are going to add another element over here. Go to sensors and drag and drop the clock. Okay, so we are going to use this clock to let the user know when was the data last updated. So you can create another text field over here or a label, rename it as, okay, I'll name it as label underscore clock. And just a second. Yeah. So initially let there be some text which will change later. And yeah. Fine. So now this is the basic UI part. Like there is nothing much in detail. So tell me if you have followed till here.
Yep.
Okay. And now let us go into like coding these blocks. Fine. These are okay. So now what is going to happen is when your screen is initialized, so you click on block. See, this is the designer thing. You click on blocks. Fine. So you get this screen. Are you in the screen right now?
Yep.
Yeah, cool. So now when you click on screen 1, you can see all these options, right?
Yeah.
Yeah, so you can select when screen 1.initialize. That is when the app is open. You can see this is the clock label, right? The clock text then. So you can select, you can set this text. That means that this label's text can be customized using this thing. So then you go to join, you go to text, join, fine. You can concatenate 2 strings here. I am assuming you have learned Python, so you should have some idea regarding this, fine. So then to get the current time of the day, you can use this thing. Go to clock 1 and select this thing. You're basically calling a function and call clock1.now.
Could you slow down just a little bit?
Yeah, sure. So you go to clock 1 and select this then dot format instant. Where is the, yeah. Did you find this?
Oh, I didn't label my labels.
Yeah, it's fine.
Do that.
It's fine.
I can't find what is what.
Yeah. So you come back to your design part.
Yeah, I'll do that.
Yeah, select it and you can rename it.
Could you go back to your blocks?
Yeah, sure. So yeah. Fine.
Almost there.
Yeah. Okay, we'll get back to this, and anyways we will be using this again. So now I told you about the list picker, right, which is basically like a drop down menu. So now you can select the list picker 1, list picker 1 dot before picking. Just a second. Yeah, my Google Assistant was active. Fine. So list picker 1 before picking. So you can set the elements of it. So you select any one of those blocks and place it over here. And elements. Okay. And now you need the Bluetooth networks to be displayed there, right? So you set list picker 1 dot elements to Bluetooth client. Fine. You go to this thing. Tell me if you followed it.
Not yet. One sec.
Yeah, sure.
Yeah.
Yeah.
Sure.
Okay, so fine. Okay, anyways, the blocks will be here itself, and
yeah, I'm right with you now.
Yeah, fine, cool. So now what you have to check is, so this one will, like it will select the element, fine, for which it has to connect. So now what you have to do is, after picking it, go to Bluetooth client, connect address, fine, list picker 1 and dot selected. So now it will make a Bluetooth connection with the selected item from the list. Okay. So once you do this, then you where is that? Yeah. You copy paste this block just to, in case you want to connect to another Bluetooth network, and you are done with this part of it. Okay. And after this one, you're going to go to clock 1. When clock 1 dot timer, it is basically like a while loop. It is basically like a while true. That means it keeps running indefinitely. Okay. It's an infinite loop. Then you're going to put a if condition. Now you are going to check if the Bluetooth connection is established. So what you can do is, you need 2 conditions over here. So you can keep one of these over here. If Bluetooth dot is connected, And now we have to satisfy two conditions over here. So we need a AND gate. So you go to logic and fine. You connect the blocks. And now we are passing two float values from the Arduino board. So now we have to make a comparison such that the number of bytes received will be greater than 8. I'll get back to that in some time. So Bluetooth client. Yeah. So what you're going to do is you're going to Bluetooth, check the number of bytes available to receive. And this has to be greater than 8. And this goes in the if part. Okay. And once you do that, you're going to create a list called as values. And you're going to go to text and select distance, split. Are you following till here?
How do you get the 8 to display?
Yeah, it's in math.
Oh yeah, got it.
Yeah, so you can just type it. Fine. So now in the text, you can go to Bluetooth client and you're going to go to receive text number of bytes. So here what you're going to do is you're calling the bytes available to receive, and that will be stored in a text over here, and you're splitting it at every comma because that's what we had done in the code, right? So yeah. So after this, you can create two more variables and you can copy paste the block. Are you following till here?
The initialize local name to.
Yeah, it's in variables.
It's not fitting in the then part.
It should. No, wait. You selected this thing, I guess.
No. Initial local name to.
Yeah, it should.
Variables, right?
Yeah, variables and.
Oh, it worked now.
Yeah, fine. So now after this one, what you're going to do is you're going to see if you're splitting it at every comma, there are going to be two elements in the list and they are going to be at index 1 and 2. So now what you can do is index 1 and copy paste. And indexing starts from 1 in MIT App Inventor. So now after this thing, you're going to get of values. Values is the list over here. Fine. Values is the list, and you're basically extracting the first and second element. So once you do that, okay. Yeah. So now you're going to set the temperature and humidity values. So what, again, the same procedure. And temperature will be in Celsius and humidity will be in percentage. So you can just add those units over here with AND. And now the values of temperature and humidity are stored in these two variables called as temp and humid. So you can use get from variables and then store it. And then what you're doing is you're setting these text values, these labels, fine, of this thing. And at last, whatever you have done, copy it. Just a second. Yeah, this full block rather. So you copy paste the full block over here. Yeah. And change it to last updated. So are you done with this?
Not yet. How do I get the one below get values?
Yeah, so you have to select this set. No, this one is again you go to math and
math, okay.
Yeah. Fine. And once you get these things, you had created those empty labels, right? With 2 hyphens. So you're setting those 2 text values over here. It is basically like assigning to a variable. So yeah. Okay. So are you done with it?
Not yet.
Is it compiling, Joseph?
I just have a bit. 1 sec. Someone's knocking my door.
Yeah, no, it's completely fine. Go ahead.